So what is meant by the factorial of a number? Suppose if it is like this. So what is the what is how to calculate the factorial of 5? Hello, hello. Am I audible or not?
It's audible.
Yes, yes. So tell me how to calculate the factorial of 5. So you know what is meant by factorial?
Yes, sir.
Yeah, yes. Then tell me what how to calculate. I'm not asking you program or something. So what mathematically you
1
calculate
into,
factorial of 5?
sir, 1
Your
into
voice
2
is
into
breaking.
3 into 4 into 5.
Yes, right. So if it is a 5 factorial, you will start multiplying from 1. So till that number, right? So you try to generalize it. So what is the factorial of n? What is the factorial of n? So what I'll say is 1 into 2 into 3 into till into n, right? Yes or no? Hello, hello.
Yes, sir.
Hello.
Am I properly audible or not? You just please respond. I'm asking you simple questions like what is the factorial of 5? How to calculate?
Sir,
I'm
1 into 2
I'm
into.
not getting. Yes, yes. I'm not getting you whether you are able to listen or you are not able to follow.
Sir, the answer is 1 into 2 into 3 into 4 into 5.
Yes, right. So I'll start writing like this. So I'll say hash include stdio dot h, and I'll start with void main. Okay. So here I'll take. So here first I'll start with few variables. So what are my variables here? So what variables I require? I require the value of n. So I'll read the value of n from the user. Okay. Then whatever variables you require here for calculation, I require one more variable, say I. So I is one variable I require. So for loop control. So for controlling the loop, I require one variable. I'll say it as I, a loop control variable. And what else variables you require? So after calculating the factorial, I'll store the result. So I'll tell it the name is res result. Okay. So first what I'll do is I'll read the value of this n from the user. Printf enter the value of n. So user will give me a value. I'll read that value scanf. Percentile d is that, and I'm storing it into the variable n. Okay, so this n is my input for this task. And after reading the value of n, so now what I'll do is I'll take a variable, say I. I'll take this variable I. So initially I'll take the value of this I as 1. And let us say my target, that is n, is Uh, Let us say it as 3. That means I want to calculate 3 factorial. So I have to, every time I have to multiply the value of I with this result. So up to what number I need to do the multiplications? Up to what number I have to do this multiplications repeatedly?
Up to n.
Up to n. So I need to iterate my loop. So up to what extent I need to iterate my loop is starting from I value 1 till the value of I is less than or equal to this n, and each time I'll increment the value of I by 1. Okay. I'll simply multiply the value of this result with I, and again I'll store that result into res itself. Result is equal to result into I, and I have to initialize this result with 1 because result by defaultly it contains a garbage. So first look here, what I'm doing here, I am multiplying the value of this result with I. If I don't initialize this result with 1, so this result will have some garbage. So what you're doing is you're trying to multiply that garbage value with 1. No, I don't want to multiply like that. So what I am doing is I have a variable, say, so result is my variable, so which I'm taking it as 1. Okay, just give me a minute. Okay, so just what I'm doing is I'm multiplying the value of this result with I. So what I'll get with what is the value of my result now? So it is 1. So because 1 into 1, so this is just 1. And after multiplying this, I'm again storing that 1 into 1 into the variable result here, right? So after this multiplication, I'm incrementing the value of my I with a 2, and I'm verifying whether 2 is less than or equal to this n value, which is 3. Yes, it is less than or equal to. So what I'm simply doing, again multiply your I value with result. So what is the value of your result into I? It becomes 2.
2.
So again, after every multiplication, I'm placing the answer, that result into I again into result. So that means in every iteration, I'm just multiplying with one number. So actually it is 1. So multiply that 1 with 1, it becomes 1. Multiply with 2. So 1 into 2, it becomes 2. Multiply with 3. So already it is 2. Now you are multiplying with 3. Now it becomes 2 into 3, 6. So once after multiplying with 3, so you are reaching your target, that is your I value is less than or equal to n. So this condition holds true only up to this point. Yes or no? When it is 3, then also you can multiply, and after 3 it becomes 4. So when it becomes 4, when you try to compare these two values, so what is the value of comparison of this? 4 less than or equal to 3. So it doesn't satisfy anymore. So when this doesn't satisfy, so you have already reached to your target and you no need to do any more multiplications. The task of your multiplication is done up to this point, and once if it doesn't satisfy, so then you can simply go and display the value. What you can display now? Printf. The factorial of percentile d is equal to percentile d. So what are the two format specifiers here? First format specifier is, so whose factorial you are calculating now? So which number you are calculating the factorial?
N.
It is n exactly. So what is the final answer after calculating the n factorial? So where you have, in which variable you have it?
Result.
I have it in result. Yes. So you can simply you can run it and you can verify. Just compile. See what is the value of 4 factorial. The factorial of 4 is 24. Okay. So you can give any number of your choice, so you'll get the answer. The factorial of 7. Got it? So this is how simply you can calculate the factorial of any number using your loops. You can write any of the loops. You can write this. You can do the same task using while loop. You can do the same task using for loop. I'll tell you one more looping statement, that is do while in the next. So you can do the same task with do while as well. So these are the different structures. So using a while loop, using a for loop. So these are the different structures. So whereas writing of for loop structure is more easier when compared to writing the other loops, because you'll have all the three parts in the single line. That is your initialization, your test expression, your incrementation. In whatever loop you take, you should have these 3 points, but according to the structure, the points will differ. In while loop, we'll write it in the beginning. So I'll show you. See, if I just make this part in the comment, so comment section means it will not be considered by the compiler. It will not be considered by the compiler. You can do the same task using while loop as well. You can write it like this. You can initialize I value here, and later you can write the test condition like this. While I value is less than or equal to n. Okay. So inside this, you can write result is equal to result into I, and you can increment the value of I here. See, whatever I have written in the for loop, I equal to 1, I less than or equal to n, I plus plus, result equal to result into I. So all the things are there in the while loop as well, but the structure is different. In for loop, it looks in a different structure. In while loop, it looks in a different structure. That's it. But it should have all the statements. Without initializing I value equal to 1, you are not telling your starting point. Without writing that I less than or equal to n, you are not telling your ending point. Up to what point you need to iterate the loop. And if you don't write I plus plus, if I skip writing I plus plus, look what happens when I skip writing this I plus plus. What happens when I don't increment the value of I? What happens when I don't increment the value of I?
It won't calculate the other number.
Yes. I value equal to 1. Always it remains the value of I as 1. See, your result is 1, right? Initially, the result is 1. And let us assume your n value is 3. See, what is the condition here? 1 less than or equal to 3. It satisfies. It multiplies this result into I and it stores here. So what it is, it means your result value is 1. And after this, it goes back and re-verifies the condition. So what is the condition? I less than or equal to n. So what is the value of I? It is still 1, and you are verifying the same old condition, which is 1 less than or equal to 3. Yes, 1 is always less than or equal to 3 because you are not upgrading the value of I. Are you modifying the value of I? No, I'm not modifying. So what happens? Always it verifies only with the I value as 1. So when I value is 1 always, your test condition I less than or equal to n, it never becomes false. It never becomes false. So what happens if it never becomes false? It will only execute this part. Up to what time? Actually, I want to execute this, iterate this loop for 3 times or n times. But if I don't modify the value of my loop control variable, the test condition which I have written will always holds true. It always holds true. So when it always holds true, the control will never comes out of your loop, which we call it as a infinite loop, which we call it as infinite loop. If the control doesn't comes out of your loop, it will never execute the statement, which is the factorial of n is equal to result. So this statement will never be executed because your control is only looping at this point itself, only in the while loop only, which we call it as a infinite looping statement. Look what happens when I have an infinite loop like this. See, I'm giving the value of n value as 4. It was simply calculating that factorial 1 into 1 into 1 into 1 into 1 into so on. It will calculate that. Once if your test expression fails, then only it will execute that print statement. If your test expression doesn't fail, it will not come out of the looping block. So you have a looping statement there that I less than or equal to n, it never becomes false. So if it doesn't becomes false, it will never execute that print statement. See, look what happens here. I have given input, still it is calculating only. Because the reason here is I have not modified, I have not incremented the value of I. So got it?
Sir.
Yes, sir.
You should have a test expression that your test expression at some point of time it should become false. If you give n value as 10, the loop iterates for 10 times. If you give n value as 100, the loop iterates for 100 times. You should have a finiteness in your loop. If you are not having a finiteness, it executes for infinite times. Like this, what happened now. So compulsorily, you should have that increment a statement in your loop. Okay. So this is how you can have an infinite loop as well. So now, hope you are clear with this for loop.
Yes, sir.
But the thing is, you have to practice more using these looping statements. Okay. Otherwise, it will be tough for you to practice until and unless you practice so you can't remember the syntaxes. And so what issues you can face if you start doing this, you will face number of issues. So I'm just trust me, you'll have number of issues when you start writing the programs on your own. Definitely you'll face number of issues. From those issues only you can learn something. If you get an issue, then only you learn something. Okay, so just remember that and you try practicing. So next we have one more looping structure, that is do while. So as I told you in the beginning, looping statements are of two types: entry control and exit control. While and for are the examples, or they are the examples of entry control structures. So those two are entry control. So now we have one more structure, that is do while. So this is an example for
Exit.
exit control structure. Okay, so do while, so you can see here, so you have to use two keywords. So one is do and the other one is while. So two structures are used, sorry, two keywords are used in this structure, do and while. And this is the only loop which is having a semicolon at the ending. So you will have a semicolon at the ending. So do, you have to write down the a pair of flower braces, opening and closing flower braces. So in between that you have to write down the body of your loop. So whatever statements you want to do, so you have to place those statements inside this loop. And then after that you have to use the keyword while, and then write down your test expression. So the test expression is written in the brackets, and at the end you will have a semicolon like this. So you can see the what we call the flow chart of this do while. So first you have to write down uh, the body, that we call it as a loop body of the do while, and then so this like this it executes. So you'll have a test expression here, and after this test expression, now it verifies your test condition. If your test expression is true, then it will simply execute the body again. See, before executing the loop body, nothing is verified for the first time. For the first time, without any verification, you are executing the loop body. This will not happen in the while or for. Here, first the loop body is blindly it executes without any verification. For after first execution of your body, then it verifies a test expression whether to execute the body for the second time or not. Whether to execute the body for the second time. If it satisfies, if it is true, it executes the body for the second time. If it is false, without executing the body, it comes out of the block. So this is what we call it as exit control structure. Okay. So is there any difference between entry control and exit control? Can someone tell me, have you identified any difference in entry control and exit control, or while and do while?
Sir, hash include stdio.h.
No. I'm not asking any programming something. Just in conceptually, Have you identified any difference in while and do while? Suppose I have a question like this. So can you tell me minimum how many number of times while loop executes, do while loop executes for any task, irrespective of the task? Minimum how many times you can say that while loop executes and do while loop executes, irrespective of the test condition. See,
Infinity.
just tell me.
Sir, it will be infinity until the unless it will added.
No, no, I'm asking not maximum times. I'm asking you minimum number of times. See, you look like this. Suppose I have written a test condition. I am not even telling you what is the condition. I have written some random test condition. Okay, that random test condition, what I have written, may be false for the very first time. Let us assume I have written a condition I less than or equal to n is my condition, and that condition is not even satisfying for the very first time. How many times while loop executes? If the condition fails for the first time,
Zero.
zero times, right? It will not execute if it is false. In the same situation, if I am writing a do while loop, how many times it executes the body?
One.
Definitely for one time, because the test condition is verified after the completion of first time the body execution, right? First time the body is executed without any verification. So I'm least bothered about whether it is a true or false in the first execution. After completion of the body for the first iteration, that is the first block execution, for the second time onwards, I'm verifying the test condition in the case of a do while loop, right? So irrespective of the test condition, I can say my while loop will execute for zero times, but do while loop will execute at least for one time for sure. Without any doubt, I can say at least I can execute a do while loop at least for one time for sure. For second time, I don't know. It is dependent on the test condition. If my test expression becomes true, then only it executes. Otherwise, it will not. So, minimum guarantee of execution of a do while loop is for one time for sure. So, got my point.
Yes, sir, got it.
So that is actually important. So we'll have some situations like I want to execute for the first time. From the second time onwards, I'll take the choice from the user whether to execute or not. So in that kind of situations, I will go for this do while. First time I'll do without any verification. From the second time, it is dependent on something. So in that kind of situations, I can use this do while loop. Okay. So I'll just tell you how to write a do while loop now. So syntactically, so we'll see. That's one example. I'll tell you one example how to write a do while loop. So I'll start with hash include stdio dot h. So I'm taking some variable, say n. So hello. So I'll read an input from the user for this n. Enter the value of n. The user will give me a value. So I'll read it into n percentile d. Hello. Please mute your mic. I'm getting a, so I'm reading the value of n from the user. So now what I want is, let us say I have a print statement like this. I have a print statement like this. So I want to display this print statement for n number of times. Suppose user gives me 100, I'll display this for 100 times. If user gives me 500, I'll display it for 500 times. Clear?
Okay, sir.
Hello?
Yes, sir.
So depending on the value of n,
Hello.
I'll display. Hello?
Hello.
Yes, tell me.
No, sir, nothing.
Nothing, okay. Okay, then please mute your mic. I'm getting some disturbance. I'm getting a voice repetition. Okay, so I'm just trying to display this statement for n number of times based on the user given n value. So what I'll do is, I'll say do. So here I'll write this statement inside this block. So for I want to write it for while. So I'll start from 1. So which is I less than or equal to n number of times I'll display. I'll repeat it. So I'll take the value of I as one more variable, and I'm starting my I value from 1. Okay, so I value is starting from 1, and every time when it enter into the block, I'll display this statement on the screen and I'll verify the condition. Okay, so every time I'll display this. So look what happens when I write like this. What happens, will it displays for how many times?
And n number of times.
Actually, if I give it as a 10, how many times it displays?
10.
Actually, this will be displayed for infinite number of times. See, it is not stopping, it is continuously, it is displaying the same statement. We observe, you can observe this a scroll bar there, so you can identify the difference. See, I'm dragging the scroll bar to the beginning again. See, it is continuously displaying. Why? Why it is displaying for this many number of times without any break?
Because it never becomes false.
It is not becoming false because my I value is always 1. So I'll also display the value of I here. You can understand. You are not modifying your I value. It is always 1. You have to upgrade the value of I. Otherwise, you will not get it. See, if I give n value as 5, see how many times? Still, every time it is 1. Got it? So what you have to do, you have to modify the value of I always. So after displaying the statement, you have to increase the value of I by 1. When I say I plus plus, so every time it will update the value of I. See, if I give the value of n as 10, now it displays for 10 times and it will stop. Okay, at the last I have one more print statement here. So I'm getting it an extra statement here. So I'm giving n value as 12. It displays for 12 times and it is stopping. So got it? Hello?
Hello.
Yes, you got it or not?
Yes, sir. Sir, in last time what you have wrote, sir? Now you have wrote 12. Last time what you have wrote?
I don't know, something, some number 5 or 10.
Okay, sir.
You can give any number. According to that number, it displays for that many times. If I give 20, the same
Sir, can
string
I
displays for.
infinity?
Can I?
Right? Infinity.
How can you write infinity? If you want to display the same thing infinite number of times, you can simply remove that I plus plus, you will get that. You have to give some number. Infinity is not restricted to your integer range. Your integer variable or integer data is having some range. In the beginning of when we are discussing about the data types, I told you what is the range of integer, what is the range of a short integer, long integer. I told you some range like 32,767 to 30 minus some number to positive some number. So you can look at there. So there you have some range for integers. You can give a number up to that point. Got it?
Sir,
Yes.
sir, can I increase the I value with 2 by not by the 1?
Yes, you can do. But what it will do is first it verifies with 1 less than or equal to, it's like say n value is 10. Hello?
Sir,
Just listen. Let us take n value as 10. I have taken the value of n. Let me change the color of this. So just I have taken the value of n as 5, and I have taken one more variable I, which is 1. So first what it is, what condition it verifies, 1 less than or equal to 3, right?
yes, sir.
Next, when I increment this I value with 2, what it verifies? I value is incremented to,
Is that equal to or less than n?
suppose if I have written like this, I equal to I plus 2. From 1 it becomes
3.
3. So 3 less than or equal to 5. And after that, when I increment this by one more time, it becomes 5. So 5 less than or equal to 5. It satisfies. And later, when I increment it again, it becomes 7. See, look here. So this becomes false. So it will stop at this point. So how many times your condition satisfying here?
Three times.
Your condition satisfied for 1, 3, and 5. But your intention is when value of n equal to 5, you want to display this statement for 5 times. But unfortunately, your condition is satisfying only for
Three times.
3 times, and it displays the same statement for 3 times. That's it. You have to write your test condition such that how many times you want to iterate this loop, how many times you want to execute this body. Just it is a small number like 5, so you are getting it for 5 and 3, so you can't identify that much difference. Suppose say your n value is you want to display it for 50 times, and every time you are incrementing by 2, so how many times it displays? For half of the times, right? Instead of 50, it displays for 25 times.
Yes, sir.
Clear?
Yes, sir. It is clear now. Thank you.
You have to write the condition in such a way. So that is the reason I'm incrementing always by 1. So got my point now?
Yes, sir. Got it.
Yes, that's fine. So we'll just go with one more example on writing a do while loop. So we'll try to display numbers from, let us take, we'll try to display the numbers in the reverse order now. So let us say user is given a number 10. I want to display the numbers in a reverse order. That means 10, 9, 8 till 1. Got it? So I'm just trying to display the numbers in the reverse order. So I'll say hash include stdio dot h. I'll take a variable say n. First, I'll read the value of this n from the user. Printf enter the value of n. So I'm reading the value of n. So now what I want is, suppose if the value of n is suppose user given n value is say 10. So first I'll write a print statement such that it displays one number, that is n. Okay, so I'll write like this. So printf percentile d, and I'll make it. So what is meant by slash n? What is meant by slash n? Hello? What is meant by
Hello.
slash n? You can hear hello, but you don't hear the questions.
New line.
A new line.
Next line.
Yes, a new line character slash n. So I'm just displaying the value of n. So that means what is the current value of n now? The current value of n is 10. So it displays the value 10 on the screen, right? I just want to make this statement or this print statement to iterate for many times. Okay, I just want to repeat this statement, print statement for number of times so that it can display one number at a time. Okay. So what I'll do is I'll simply say do, I'll write this print statement. So that means after displaying the value of n, so what is the next statement I need to display? Next number I need to display after 10. Hello? Which number I need to display after n? That means after displaying 10.
Result.
No, no, no. I don't have any result. I'm not doing anything. I'm just displaying the numbers in the reverse order.
9.
9. So to get 9, what I have to make on n?
8.
-1.
What operation you need to? Yes, I'll simply say n minus minus. So what n minus minus will do? It will decrement
Train
the
sound.
value. Hello?
That one train sound.
What you will do with the train sound? So it will just decrement the value of this n by 1. So after 10 it becomes 9. After 9 it becomes 8. Later it becomes 7. So up to what point I want to decrement this value of this n? Up to what point you have to you need to decrement? So my task is to display numbers from n to 1. So 1 is the last number. When it prints 1, I want to stop. So what might be your test expression here?
Equals to 1.
So when I say n equal to 1, it will only go to the loop when the value of n is 1. If it is not 1, it will not do. That means if I say n value, that means if n value is 10, after decrementing, what is the value of n?
9.
It becomes 9, right? So when this becomes 9, it will verify 9 equal to 1. Is 9 equal to 1?
No.
No, so it will not go back. So it will not re-execute your body. Then what might be your test condition? So I want to repeat it further when it is 9, when it is 8, 7, 6, 5, 4, 3, 2, 1. And after 1, when I say minus minus, it becomes 0 and I want to stop there. So when I am repeating is when the value of n is greater than 0, right?
Yes, sir.
When the value of n is greater than 0, I'm repeating. Or else you can say like this: when the value of n is greater than or equal to 1, I'm repeating. Anything is fine. You can say greater than 0 or greater than or equal to 1. Both will give you the same one. When the value of n is greater than 0, I will repeat. When it is equal to 0, I will not do. See, so I'm just compiling the code. It got compiled. So I'm just giving the value of n as something like 10. So it will stop when it becomes 1. Wherever you start, it becomes 1, it will simply stop. I can say 100. Yes, it starts from 100. So when it becomes 1, it will stop. So it will display all the numbers from that point n to 1. So got it?
Yes, sir.
Yes or no?
Yes, sir.
Okay, you just try for one more program. I'll tell you. See, remember, I can just only give you some task, but I can't verify your task everything, so whether you have done it or not. So that is up to your thing. So whether to do it or not. So if you do the things, you if you get any problem or you get any error or you are not getting, so that we can discuss in the next class if you do it. So otherwise, it is not responsibility of me to verify your whether you have done or not. So that is not our. So you are not just a school kids like I can verify your homework or something like that. If you try to attempt it, if you face any issues, then we can discuss in the next class. So my job is up to give you some task, or whether you do it or not, that is your thing. So you want to do, you can do, otherwise just I can't do anything. Okay. So what you do is you take a value, you take some input from the user, say it as n. Okay, if user gives a number 10, so you start displaying like this: 10, 8, 6, 4, like this up to, you can stop up at a point of 1. Suppose if user given number is 15, so you display like this. So 15, 13, 11, 9, so like that you can display. So till the last point is 1 always. Here means every time you try to decrement its position by
2.
2. So you try attempting this one using, you can do the same task using all the 3 loops. You can use it with while, you can do it with for, the same thing you can do for do while as well. So you try to attempt this task with all the 3 looping structures. Okay. So Sal, you have any doubts? So you can just tell me. So I'll just discuss. So no doubts, man. So we can leave.
Okay. Good night, sir.
Okay, Nana.
Okay,
Good
sir.
night. Thank you. You can stop.